You hear the buzzword all the time, right? Smart manufacturing. But what does that actually mean? Today, we're cutting through the jargon to explain how a modern factory really operates. Spoiler alert, it's less like a static building full of gears and way more like a living, breathing organism. Let's dive right in and demystify the future of the factory.
So what exactly makes a factory smart? Well, think about a traditional assembly line. It was built to do exactly one thing, over and over. If you wanted to change the product, you literally had to stop everything, retool, and start from scratch. A smart factory totally flips that script. By deeply integrating digital tools, the facility can actually think, react, and adapt in real time.
The formal definition we're looking at here boils it down to this. It's a broad category of production that relies on computer-integrated manufacturing and digital IT. But why does that matter? It's all about adaptability. A design change that used to take weeks of intense physical labor, that can now happen almost instantly because dynamic digital data is driving the machines, not just fixed physical gears.
Now, it is super easy to get mesmerized by all these machines, but let's be real, none of this works without human ingenuity. That's why a huge pillar of this whole movement is flexible training for the technical workforce. The people on a smart factory floor aren't just, turning wrenches all day. They're essentially tech operators. They're real-time problem solvers managing some incredibly complex digital systems.
Okay, so how does this actually take shape on the floor? It all starts with networked sensors. You can think of these literally like the nervous system in a human body. They are embedded everywhere, on the assembly lines, inside the machines, tracking the raw materials. They capture every tiny vibration, every temperature spike, and every movement, instantly giving us a real-time pulse on the factory's health. And all that insane amount of sensory data doesn't just sit there in a vacuum. It feeds directly into interoperable systems. Interoperable is really the magic word here. It means machines from totally different brands, running completely different software, can actually talk to each other in a shared digital language. Because they can communicate, they drive what we call intelligent automation, meaning they adjust workflows on the fly without waiting for a human to push a button. Which leads us to honestly one of the coolest, most futuristic parts of all this, multi-scale dynamic modeling. Because the entire factory is mapped out digitally, operators can run incredibly complex simulations. Imagine stress testing a massive, completely new production run in a virtual sandbox before a single real-world machine even powers on. You find the bottlenecks in the digital world first, which saves a massive amount of time and resources.
But with all this amazing connectivity comes a very real vulnerability. Strong cybersecurity is absolutely not an IT afterthought here. It's a foundational necessity. Since every sensor and system is networked, the factory essentially becomes a digital fortress. Protecting it from external hackers or internal breaches is literally just as critical as the physical manufacturing itself. Basically, a smart factory is only as strong as its digital armor.
So if we look under the hood, there are three core technologies really driving this engine. If the sensors are the nervous system, big data processing is the brain making sense of everything in real time. Then your industrial connectivity devices are the pathways that allow for that seamless communication. And finally, advanced robotics step in as the muscle to physically execute the automation. Brain, nerves, and muscle, all working in perfect sync.
So what's the ultimate goal here? It's solving a massive, age-old business problem. In the old days, you'd guess what you might sell, build a huge batch, and basically just cross your fingers. Smart factories allow for demand-driven production. If a product suddenly goes viral online, that data flows straight back to the floor. Production scales up instantly to meet that exact spike, which pretty much wipes out both inventory shortages and the ridiculous costs of overproduction.
And that instant reaction time creates this massive ripple effect that optimizes the entire supply chain. When the factory knows exactly what it needs to build today, it knows exactly what raw materials to order for tomorrow. Suppliers get updated automatically, shipping routes adjust on their own, warehouses aren't stuck holding unused parts. The intelligence on the floor radiates outward, streamlining the whole logistics process from end to end.
Ultimately, this unprecedented level of data control leads to highly efficient production and a huge boost for sustainability. Because the system uses every single ounce of raw material with microscopic precision, physical waste just plummets. Plus, having everything so tightly documented makes sorting and recycling materials at the end of their life cycle way easier. It's better for the bottom line, and obviously significantly better for the planet.
As we wrap up this explainer, looking at the sheer scale of these advancements leaves us with one pretty provocative question. How quickly will these technologies shift from just being a competitive advantage to the bare minimum standard? The transition from rigid assembly lines to living, dynamic manufacturing is already happening. The question really isn't if the future of the factory is smart, it's whether you and your industry are ready to adapt to it. Thanks for exploring this with me.